Okay, now we are going to look at the second problem on Bayes' theorem, which is about diagnostic tests. So let's read the problem. So a diagnostic test has a probability of giving a positive results when the person is suffering from a disease is 0.95, and the probability of a test giving a positive result when the person is not suffering is 0.10, and the total number of population suffering, or the total percentage of population suffering, is 0.5%. And we want to answer these four questions, which is: what is the probability that the test is positive, and what is the probability that somebody suffering from a disease given the test is positive, and the third question is probability somebody is not suffering from disease when the test is positive, and then what is the probability of misclassification. So I'll give you a couple of seconds to go through the question while I prepare the whiteboard. Okay, so let's start from the basics even before we go into the problem. Let's review some of the concepts that we know: Bayes' theorem, we know, and Markov chain rule, right? So the first one, Bayes' theorem, probability of A given B is can be expressed as probability of B given A times probability of A by probability of B. And the second one that we know is probability of A B, which is A intersection B, can be expressed as probability of A given B times probability of A, which is same thing as probability of B given A times probability of B. So this is Markov chain rule, the second one, and this is the Bayesian theorem. And you can see that Bayesian theorem can be derived by just putting this denominator under this one, and you get the Bayes theorem. So let's go back to our problem and try to define it in terms of symbols. So let's define the problem. Let's say next page. Um, so what the problem is saying, is let's define the symbols. So if the test is, t plus is, we will say that test is positive, t minus, test is negative, s plus, suffering from disease, and s minus, not suffering, right? So, and what is so these are the symbols that the first step is to take the problem and convert into symbols so that it's easier for us to express in terms of probability. So what is given to us? Let's from the problem, if you just forgot the problem, let's look at this again. So what we are given is probability is 0.95, probability of 0.10, and probability of 0.005. These are given, and then let's put it in terms of the symbols. So so we are given probability of this test is positive given somebody is suffering, right? Is 0.95. Probability of test is positive when somebody is actually not suffering is 0.10. Remember, this is not summing to 1, and we should not expect this to be summing to 1. So that's some confusion people often get into. And what is the probability of people suffering in general in the whole population is 0.5%. So which if we express in a fraction, it's 0.005. So we can easily derive, s minus is equal to 0.995. So this is a derivation. So and then from actually, so let's what are the question being asked? So let's what are the questions? Um, so the first question is, what is the probability of a positive test? So remember, from the given items, we don't really see anything, that says about positive test. So we have to somehow express in terms of whether they are suffering or not suffering. So this one can be easily expressed as probability of, test is positive, and in all the cases, which is somebody suffering or somebody is not suffering. So this will cover all the cases, and then you can simply expand it as saying probability of test is positive and somebody is suffering, and probability of test is positive and somebody is not suffering, right? So given these two, now it's easier to express this term from Markov chain rule in terms of these. So remember, this one is equal to probability of t plus given s plus times probability of s plus. So based on this Markov chain rule, plus probability of t plus given s minus times probability of s minus. So you just need to substitute these values here. So which is going to be 0.95 times 0.005 plus 0.10 times 0.995. So you will see that probability of t plus is 0.10425, right? So he answered the first question. Let's look at the second question. So the question is simply probability. The second question is, what is the probability of somebody suffering given test is positive, right? So, or in other words, probability of s plus given t plus. How do you express this one? Um, so remember, we use Bayesian theorem here, so we just say s plus given t plus is equal to probability of t plus given s plus times probability of s plus by probability of t plus. So we already computed this one here. So we are going to just substitute that 0.425, and then we're going to put these two values. It is like 0.95 times 0.005. So this one will be equal to 0.0455. And if you want to compute probability of S minus, given the test is positive, it's a difference from this one. So you can simply calculate the difference and you can compute. Let's look at the next. Actually, let's change the problem a little bit and say, what is the probability of somebody not suffering when the test is negative? Right? So let's so how do you express that one? What is the probability of not suffering given test is negative? This one can be expressed as s minus given s t minus is equal to probability of um, t minus given s minus times probability of s minus by probability of t minus. So we have computed probability of t plus, and then probability t plus is equal to, remember from the previous slide was this one, probability of t minus is essentially 1 minus probability of t plus, is equal to 0.954445, right? And what is the probability of t minus given s minus is equal to 1 minus probability of t plus given s minus. So we know these values, we substitute these values, and we get it's like 0.90 times 0.995 by probability of 1 minus 0.9545 is equal to 0.9997. So this is the probability. Essentially, this is the third problem. Problem 3. So E is 0.997. Let's look at problem 4, which is probability of misclassification. So probability is misclassification when we have test is positive and the person is not suffering, or test is negative and the person is suffering. So this one you can compute, and then we using Bayes theorem, we actually Markov chain rule, we said probability of t given s minus times probability of s minus plus probability of t minus given s plus times probability of s plus. So we can substitute the values for s minus, s plus. We already compute this is t plus given s minus here. Yeah, it's actually this is already given, and this one we already computed. So if you substitute the values, we'll get 0.9975.